Okay, today we'll look at the last part of the guide, which is being able to write an equation given a function or just interpreting a function. So here we have a pebble, or actually a bicycle wheel, and the person's foot is on the pedal going around. So you can see that it's periodic. The person is cycling and it's going around and around and around. So looking at the graph, the first question says, how far above the ground is your foot at time 0? So we can see here that it is 5, I believe this is in centimeters. So time is in seconds and height is in centimeters. Okay, so the person's foot from the ground is 5 centimeters. The amplitude, remember, is the vertical distance between the middle and the top or the bottom. So we can measure it. So the middle is at 20, the bottom is at 5. So we can tell that the amplitude is 15 centimeters. Explain why the radius must be 15. Well, the radius is the same as the amplitude, right? The radius of a circle. So think of it as a bicycle wheel with a circle, right? And you're pedaling. Here's your foot, and you're going around the circle. So here's your foot. So the radius of the wheel or the pedal arm is the same as the amplitude of the graph. How far is the center above the ground? Well, it is actually 25 centimeters above the ground, because here's the ground. Sorry, not 25, 20. So it's 20 centimeters above the ground. You can read that off the graph. The period is the time it takes to go through one cycle. That was actually given in the question as 10 seconds. That was just missing from the graph, so it takes 10 seconds to go around once. And how long does it take to make one rotation? Well, that's the same answer, right? The period and the rotation of the wheel are the same measurements. So you may be given a graph that you have to interpret some information from just by reading off the graph. You will also be asked to write the equation of a function given the graph, or it might be a word problem. So we're just going to go through the steps on how to do this. I think I'll do this one first. Okay, so step 1 is to find the middle, because most of our measurements are based from the middle. So to find the middle, we're going to take the top of the graph and the bottom of the graph and divide by 2. Okay, because that's our average of the middle. So the top of this graph is 6. The bottom of this graph is 1. So we'll add those numbers together. Oh, sorry, not 1. It's at -2. It's below the x-axis. So 6 plus -2 divided by 2 is 2. So that is the middle of the graph at 2. So I'm going to draw that on here. The middle of the graph is also the vertical shift. Because remember, we're going to be writing the equation of the function, and we're going to write in our transformations. So we want to know the vertical shift or stretch, which is also the amplitude. We want to know the vertical shift. We want to know how the period of the graph has been stretched, and we might have a horizontal shift. Okay, so here I found the vertical shift, the middle. So we know that the vertical shift is 2. So that's my B value. Now we're going to find the amplitude or the vertical stretch. So the amplitude is going to be the difference between the top and the bottom. So max minus min divided by 2. So we'll take the top at 6, we'll subtract the bottom at -2, and that gives us 8/2, so the amplitude is 4. And we could also read that off the graph. I could look at the graph. Now that I know where the middle is, I could count the squares to see how much the amplitude is. So from here at 2, I'm going up 1, 2, 3, 4 squares or down 4 squares. So the amplitude is 4. The next thing I would find is the value of C, which is the horizontal stretch or compression. So when we were finding the period of a graph, we would take the normal period of 360 degrees and we would divide by C. So if we want to find C, we'll take the 360 degrees and divide by the period. So the period of this graph to go through one cycle, so I'm going to start here and end here. That's the same starting point, so that is 8. So 360 divided by 8, let me grab my calculator, is 45. So C is 45. So here's my equation, and then I have to decide whether to use sine or cosine. So you kind of want to use the easiest one. So this one, I'm going to use sine because it looks like sine, right? Here's the start, and here's one cycle. And that looks like sine because it's starting where it needs to start, at 0. So it's easier for me to use sine in this one. So I know the amplitude is A, which is 4. I'm going to use sine. I know the C value, right? So what I want to do is the amplitude, the C value, and the B value. I don't have a horizontal shift of D because I'm starting where I'm supposed to start. So my C value is 45. That gets multiplied by T for time, or maybe we'll use height. So H is my Y value, and then the vertical shift is up 20. So that would be my equation of this function. Okay, or you could use Y. You could use Y and X. It's fine too. Okay, so we found the middle first, which is our vertical shift. So that was, oh, I'm sorry, I'm using the wrong numbers here. I was looking at the previous graph. So my middle is at 2, sorry, not 20. At 2. This is at 2. Okay, the middle was at 2. So the middle was at 2, the vertical amplitude was 4, and the value of C is 45. Okay? So if I was doing this one, I'll start by finding the middle. So the top plus the bottom divided by 2. So the top of this graph looks like it's at 4. The bottom of this graph looks like it's at 0.8, and I'll divide by 2. So 4.8 divided by 2 is 2.4. So that's where my middle is. So I'm going to draw that on here. So 2.4 be approximately here. So my vertical shift is 2.4. Okay, then I'm going to find the amplitude, now that I know where the middle is. So the amplitude is the maximum minus the minimum divided by 2. So it'll be 4 minus 0.8 divided by 2. So what's that? 3.2 divided by 6, or 2 is 1.6. So that's my amplitude. Okay, so this vertical distance is 1.6. The period is where we repeat one cycle. So it looks like you want to try to pick a pretty good point. So it looks like maybe I'll start here at 2.5 and then it ends here. There's one cycle. at 17.5. So it looks like the period is 15. Usually the graphs are fairly easy to read. So it looks like the period is 15. So the C value is 360 divided by the period. So it's going to be 360 divided by 15. So we'll just calculate that. And that is 24. That's my C value. And then I have to decide whether I'm going to use sine or cosine. Okay, so both of the sine and cosine graphs don't start at the beginning. So normally, here's the middle. Normally sine would start here, right? Start of sine. So it's been shifted to the right, 2.5. So the starting point of sine has moved to the right, 2.5. If I were doing cosine, cosine normally starts here, so that's been shifted to the right about 5. So depending on whether you want to use sine or cosine, if you use sine, you have to shift the starting point to the right. So this starting point is shifted to the right. Or if you use cosine, which is always at the top, at the start, it's been shifted to the right 5. So you could write it in either form. So my equation would be amplitude is 1.6. If I use sine, the C value is 24, and the starting point has moved to the right 2.5, and the middle is at 2.4. If I use cosine, everything stays the same. Amplitude is still 1.6, C is still 24, but the starting point has moved to the right 5. So the only thing that changes between sine and cosine is where you start. Everything else is the same.